Hello everyone. So today we are back with a new topic which is electromagnetic energy. In the last two sessions we studied about concept of remote sensing, how the remote sensing has evolved over the years, about the types of remote sensing and also about the advantages and disadvantages of remote sensing. So in this session we are going to talk about the most basic and the fundamental pillar of remote sensing, which is electromagnetic energy or electromagnetic radiation. In short form, you can also say it as EMR. So, first of all, it is very important to understand that what is electromagnetic energy or what is electromagnetic radiation. Basically, electromagnetic energy is a form of energy which is emitted or reflected from the objects which are found on the Earth's surface in electrical manner or in magnetic wave form. So, if you look at the term electromagnetic energy, the term electromagnetic is itself composed of two terms, electro plus magnetic. So, electro means electrical and magnetic means magnetic waves. So, in simpler terms, electromagnetic energy is basically an energy form which can be which can travel through space in either electrical form or either magnetic form. There are many examples of electromagnetic energy. Some of them are gamma rays, X-rays, ultraviolet radiation, visible light, microwave, radio waves, and infrared radiations. So, after learning about electromagnetic energy, we will move on to electromagnetic spectrum. As it is a very different term, we will try to understand that what does electromagnetic spectrum means. Spectrum means basically an array or basically a format in which all the examples of electromagnetic energy are composed or are placed. Electromagnetic spectrum, you can also understand electromagnetic spectrum as a full band in which different energies are put side by side to each other in some similar format. So this format is either can be from low wavelength to high wavelength or from high wavelength to low wavelength. So as we know that there is an inverse relationship with frequency and wavelength. If the frequency is higher, then the wavelength will be lower. And if the frequency is lower, then the wavelength will be higher. So in electromagnetic spectrums, we can find many instances in which the energies are put together not on the basis of wavelength but also on the basis of frequency. So, first of all, the electromagnetic spectrum is the range of frequencies of electromagnetic radiation and their respective wavelength and photon energy. As we knew that it is an array or it is a range in which electromagnetic radiations are put together according to their wavelengths or according to their frequencies. So this frequency, the frequency of electromagnetic radiation is divided into separate bands and which gives them the name of separate energies like X-rays, gamma rays, ultraviolet rays, microwaves, visible, infrared and so on. Each of these bands of energy have their different use. Like infrared can be used to detect the temperature, visible band can be used to see a particular feature, microwaves can be used to penetrate through cloud and soil, X-rays and gamma rays, ultraviolet rays, and so on. So this is a basically electromagnetic spectrum. In this electromagnetic spectrum, you can see that it is starting with gamma rays and ending at radio waves. So the gamma rays have the shortest wavelength and the radio waves have the longest wavelength. Here we can also see the inverse relationship between the frequency and the wavelength. At gamma rays, the frequency is the highest but the wavelength is the shortest. Whereas in radio waves, the frequency is the lowest but the wavelength is the highest. So this is a electromagnetic, this is a figure which shows electromagnetic spectrum. Now we will move on to our next topic for this session, which is EMR interaction with atmosphere, or we can understand it as what happens, what processes takes place when the electromagnetic radiation interacts with the atmosphere. So as you all know, due to our previous sessions, that when the EMR travels from the source of energy towards the Earth's surface, in between it gets interacted with the atmosphere. So this is the second stage of remote sensing data acquisition. So while the electromagnetic radiation interacts with the Earth's surface, sorry, while the EMR interacts with the atmosphere, many types of processes takes place. More two important processes of these are scattering and absorption. First of all, we will look into scattering. So what is scattering? Basically, scattering is unpredictable diffusion of radiation by particles in the atmosphere. As you all know, that atmosphere is basically a blanket which is covering the earth, and it is comprised of water vapors, dust particles, and water droplets, and so on. It is comprised of many types of particles. So when the EMR travels through the atmosphere, it interacts with the particles that are present in the atmosphere and gets diffused, and that unpredictable diffusion of these EMR is known as scattering. There are basically three types of scattering. They are Rayleigh scattering, Mie scattering, and non-selective scattering. Now, we will go into detail to study or to understand about these three types of scattering. First of all, Rayleigh scattering. Basically, these three scattering are divided on the basis of the size of the particle, the diameter of the particle with which the EMR is interacting. So, in Rayleigh scattering happens when the EMR interacts with the particle whose diameter is smaller than the wavelength of the EMR. So we can say Rayleigh scattering always happens when the diameter of the particle with which the EMR is interacting is smaller than the wavelength of the EMR. Okay. In Rayleigh scattering, the radiation is scattered equally on all the directions. Basically, the phenomena of blue skies is the result of Rayleigh scattering. Now, in Mie scattering, the interacting EMR has the wavelength which is equals to the diameter of the particle with which it is interacting. So, it always happens basically due to water vapors and dust particles that are present in the atmosphere. Now moving on to non-selective scattering, it happens when the particle diameter is larger than the wavelength of interacting EMR. So whenever we see white clouds in the sky, that is due to the non-selective scattering. So as you have seen that all these scattering are based on the wavelength of the EMR which is interacting and upon the diameter of the particle with which the EMR is scattering. So we can say that scattering is the reason of various processes or various phenomena that we see into our day-to-day lives. Now we will come to absorption. Absorption is one of the other phenomena or one of the other processes which happens while the EMR is interacting with the atmosphere. So absorption basically means the loss of energy. Whenever the energy or the EMR, whenever the energy or the EMR is neither getting scattered, neither getting reflected, or neither getting transmitted, it is taken to be lost. So the effective loss of energy to atmospheric constituents is known as absorption. Basically, the most absorbent particles in the atmosphere are water vapor, carbon dioxide, and ozone. There is a figure in which you can see that some of the energy is absorbed. It is neither getting reflected or neither getting transmitted. So scattering and absorption are the two main processes which happens or which takes place when the EMR interacts with the atmosphere. So in our next session, we will move on to interaction of EMR with the Earth surface features and onto spectral response patterns. So thank you for today.